covering actually the rest of chapter 6. So we'll be covering 6.3, 6.4, 6.5, 6.6. And the reason why we can cover that much is because you're going to see how quickly and easy it is to do stuff using our calculator. So what we're going to do right now, 6.3, is solving systems of equations like we did in 6.2 by hand. But now you're going to quickly see how you can do it with your calculator. So what we're going to do first is kind of introduce ourselves. Do you have a calculator? Because you're going to want a calculator today.
Everything's in my car.
Okay.
I don't have the strength to go back.
Okay. Because you're gonna want one of these. So, so what we have here going on is a matrix, and if you say it plural, it's matrices. You guys are pretty young, but anybody watch the movie Matrix with Keanu Reeves back in the day? Okay. So it always reminds me of this when we talk about it. So what it is, it's just an arrangement of numbers. But if you go back to what we learned in 6.2, remember how we wanted variables to cancel out, like you wanted a positive and a negative and so forth? We were just concentrating on the numbers, right? We didn't really care about the x, y, and z. When we were doing the math with the coefficients. And that's what matrices do. They pull the coefficients out and kind of clean it up a little bit, and you don't clutter it with your variables x, y, z, all right? So let's look at what we need to know. A matrix is called an order of m by n, where m is the number of rows, so it's always row by column, okay? So this order is row by column. What do I mean by that? If you look at this one down here, it's 2 rows and 3 columns, so it's a 2 by 3 matrix. And that's going to be important to know, because when we type it in our calculator, before we can even type it in our calculator, we have to tell our calculator the order, so they know how big or small or what shape to make the matrix. Another thing we want to keep in mind is every little part of it, which are technically coefficients coming from equations, they're all called entries or elements, all right? So in this section, we're going to use augmented matrices. Augmented matrices are exactly what we did in 6.2, where we took an equation, but we multiplied it by 3, or -2, and so forth. That's what we're going to be doing with these matrices, but I was talking to Corey about this yesterday. Our calculator is going to do all that. So that's what blows my mind, is somebody smart enough to program our calculator to do all that math that we were just doing by hand. So it says a system of equation is a set of 2 or more equations and 2 or more variables. A solution to this system is an ordered pair or an ordered triplet or whatever it may be that satisfies all the equations in the system. In past courses, you may solve them algebraically using substitution or elimination. We did elimination because you can't do substitution in 3 variable, but if you have 2 variables, you can do substitution. All right, so let's see what's going on. So on example 1, it says use an augmented matrix to solve the system of equations. So up until now, we could do what we were doing on 6.2, where you say, hey, notice the y's have opposite signs, so I can just multiply the second equation by 2, and I would get my y to cancel out, and we'd go from there, okay? So instead of doing that, we're going to let our matrix do it for us. So let's look at the steps over here. The first one says, represent your system using an augmented matrix. So we want it to kind of look like this, okay? So step number 1, we're going to write 4, 2, and then we do this vertical line. It's kind of like the equation or the equal signs. And then 3, -1, 2. Does everybody see where all the numbers came from? Do you not even have a writing utensil?
I have nothing on me.
Does anybody have a pencil they can let him borrow?
I didn't think it would take that long. It took an hour. I went there at noon.
It's crazy. Thank you. All right, so does everybody see where the numbers came from? So I'm just pulling the coefficients from the 2 equations, and then we typically, your calculator will not show this vertical line, but typically when we're using a matrix to represent it, we are showed, okay, this is our variables x, y, this is the constant that they're equal to. All right, so this is where you're going to want to be using your calculator. So number 2, we're going to go to RREF. And you're like, what does that mean? Well, what we were doing, it's kind of a version of this, but it's called RR, means row reduced echelon form. So it's just a mathematician that was able to come up with these things. How we do it is we first need to put this in our calculator, okay? So if you look right above your x to the -1 button right here, do you see how it says matrix right on top of it?
Oh, yeah.
So hit second matrix. And what we're going to do is, these are the matrix we're going to be using, okay? But what we need to do is we need to change them each time we have a new matrix. So that's when you go over to edit, all right? So we're gonna scroll over to edit. You can pick any of these. I've been messing around with it, so I have a bunch in there, but I usually just pick the first one because it's just easy. So you can pick one or hit enter. And the very first thing you'll see in highlighted, like it's kind of flashing, you have to do row and column, right? So how many rows do we have?
2.
2. And how many columns do we have? 3. And when you hit enter, notice it shifts to the appropriate size that you need, all right? And then what you're going to do is one by one, you're going to type in your entries, and it goes left to right. So we'll do 4, enter, 2, enter, 11, enter, and then it hops down to the second row. 3, enter, -1, enter, 2. If you're not going to use your calculator, let him have it.
I already did it.
How did you do it so fast? Somebody's got skills. You remember all that stuff, how to find it?
Yeah, I don't remember how to solve it, but I do.
That's awesome. No, that's props to you, because I haven't seen it and I'm like, I don't remember how to do this. Guys, this is where you're gonna go every time when you have to enter it into your calculator, okay? You always go to second matrix and scroll over to edit. So he remembered that. And I think it's one of those things that you end up doing a decent amount that you do just remember it. You don't have to necessarily have my calculator cheat sheet or whatever it may be. Okay, so we're gonna get out of here. So we hit second mode or second quit and we're on the main page. Now, we're going to be doing a variety of things with our matrices. So in 6.3, we're going to be solving them. That's when we're going to use the RREF, row reduced echelon form. In 6.4, we'll be doing math with them. We'll add them, we'll subtract them. And so we'll just use, your addition and multiplication symbols. But wherever we need to go, matrix is always where we need to pull it up, okay? So what we're going to do is we're going to do second matrix again. We're going to go to the math. What math we're going to do is pretty far down, so I end up scrolling up to row reduced echelon form. So see how there's 2? There's REF, which is just reduced echelon form. And what that does is it technically just solves for Z or just Y, and then you would still have to go back and plug it back in. But if you do RREF, row reduced echelon form, it gets everything solved, your X, Y, Z, and you're just done, okay? So go ahead and hit enter. It will pop up on your screen and it'll be waiting for you. Like, what matrix do you want me to row reduce? Well, what matrix did you type yours in? Did you just do A like I did? Okay, so you just go back to your matrix option. See how A is the first one chosen? You can hit 1 or enter and look what it has, okay? So you're like, well, okay, but how does that help me? Let's write that down, okay? So number 2, let's write our row reduced echelon form. It's 1, 0, and then the equal sign is 1.5, and then it's 0, 1, 2.5. And you're like, okay, Molly, why is that good? Like, why has that helped me? But remember where this matrix came from. These were the X's, these were the Y's, these were the answers, right? So what do you have? You have X equals 1.5. What do you have? Y equals 2.5. So there's your answer. So this is equivalent to just X equals 1.5, Y equals 2.5, right? The coefficient of X is 1. There's no Y's there. The coefficient of Y is 1. There's no X's there. And so your ordered pair, guys, would just be 1.5, comma, 2.5. And that's why I said what's crazy is that this calculator has been programmed to either do the elimination or substitution method that we were doing to solve that. Isn't that great? Okay, so this is something like we were seeing in 6.2, correct? We were seeing these 3 equations where when we're doing 6.2, you might say, oh, I'm going to take these top 2 and I'm going to multiply the second one by 2 so my y's cancel out, and you had to do all that math. Well, now what we can do is we can put it in our calculator. This is a 3 by 4 matrix, and we can just row reduce it, okay? So step number 1, let's write the matrix. 1, -2, 3, vertical line, -4. 3, 1, -1, 0. 2, 3, -5, 1. Okay, so this at least shows me that, hey, this is what I intended to type in my calculator. If you get the wrong answer, then I'll just know that you accidentally input it in correctly, okay? So again, what we're gonna do is anytime you need to edit your matrix, you go to second matrix, scroll over to edit. You might as well do A again because you're already done with the other A, right? Edit it, and we decided this was a 3 by 4. So you hit 3, enter, 4, enter, and it automatically shifts to what you need it to be. 1, -2, 3, -4, 3, 1, negative 1, 0, 2, 3, negative 5, 1. Is that okay? Once you get it out, you just hit second quit, you get out to your main screen, you're like, okay, what am I doing to this matrix? Am I adding it, subtracting it? You're solving. So we're gonna go to row reduce, and where that is second matrix, go over to the math, I scroll up, you can scroll down to RREF. What matrix do you want to row reduce? I put mine in A, you might have put it in something else, it doesn't matter. Hit second matrix, A is the first thing chosen, and there it all is. Isn't that a lot easier than all that stuff we did in 6.2? Okay, so 2, I'll write this down so Gavin can get this down and he knows where everything's coming from. Our reduced row echelon form is 1, 0, 0, negative 1, 0, 1, 0, 6, 0, 0, 1, 3. So the first row solved for x, the second row solved for y, the third row solved for z. So what is our ordered triplet? Negative 1, 6, 3. Isn't that great?
Yeah.
Pretty nice. Just real quickly, I want to show you before we go on the difference between row reduced and just reduced echelon form. So I still have A in there, so I'm just going to do second matrix, and I'm just going to do the math. You don't have to do this with just reduced echelon form. And what it does is it just solves for, oopsie, let me hit math frac. So notice what it's done, it's kind of dark, sorry. It's solved for z is 3, okay? And then it's reduced this to y and z, and then, so what you can go do is plug z in. Kind of like we were doing by hand. Remember, once you found one variable, you went up a step and plugged it in and found the second variable, and then you took those two variables and you went up to the original and you plugged those two in to find the third. That's what reduced echelon form does. It only finds it for just the first variable z. So z is 3, so you'd go back up, and this equation would be y minus 10/7 z equals 1, but you'd plug 3 in for z and do the math and find y. And then you get y and z, and then you go back to that top equation, and that top equation is x plus 1/3 y minus 1/3 z equals 0, but you'd plug what you found for y, plug what you found in for z, and you could solve for x. So it's really unnecessary. If you were doing by this, because all the stuff that we're doing with matrices right now, you could be doing with matrices by hand and doing all these flip-flops and stuff. This is like a step before you get to the row reduce, basically, okay? Because you would say, okay, how can I get these to cancel out? I'll multiply this by 10/7 and add it to that, and it just gets kind of complicated. So anyway, if you have no questions, let's go ahead and flip it to the top of page 2. We're now into 6.4. Watch out, okay? So 6.3 was using matrices to solve for systems of equations. 6.4 is doing operations with matrices, and it's exactly what you would think. Before we get too far in, so notice they gave us 5 matrices A through E. We're not going to use all of them. We're going to use A, D, and B. So let's go ahead and just put A, D, and B in our calculator, all right? So in our calculator, we're going to hit second matrix. I'm going to go edit A, and I'm going to make AA, okay? What is he? He's a 2 by 3 matrix. 2 by 3. So this will be 3, 1, negative 1, 2, 0, 3. Is that okay? When you get done with him, you can go second quit, because you always have to get out of him. And then go to second matrix again, edit. Let's edit B now. What is he? He's a 3 by 2. Gavin, you just make sure I'm entering the stuff in correctly. So this is 1, 6, 3, negative 5, negative 2, 4. Is that okay?
I'm really slow. I'm sorry.
It's okay. I'm used to this, so
3 by 2?
it's all there. So you just look at B. It's a
Oh, yeah.
3 by 2 matrix. You put in all of his entries. Once you get done with that, you hit second quit. Do second matrix. I'm going to edit D, and I'm actually going to go down to D, so I keep that in mind. 'Cause you could put him in C, but then it'd be confusing. So I'm actually going to go all the way down to D, because he's the only other one we're using. And D is a 2 by 3, okay? So 2 by 3. So negative 2, 7, 1, 0, 4, negative 5. Is that okay? So we have everyone in there. So I know Gavin doesn't have his calculator right now, but he can actually do A, B, and C with us. Because when it comes to addition of matrices, it's just literally adding or subtracting the entries that are in the same spot, okay? So in order to add or subtract, you have to have just equivalent entries, okay? So notice A and D are the same size. They're both 2 by 3 matrices. So how are we going to come up with the addition? We're literally just going to take the first guy in A, which is 3, and add the -2. So we can do it by hand pretty easily, okay? So let's just show that real quick, and then we'll just double check it with our calculator. So I'll show it what we're doing. Just doing 3 plus -2, and I'll just show it. Then we're going to do 1 plus 7, and then we're going to do -1 plus 1. Does everybody see where all those numbers came from? Then I'm going to go to the bottom row. This is 2 plus 0, 0 plus 4, and 3 plus a -5. Okay? So then we just do the math with them. So 3 plus a -2 is just the same thing as 3 minus 2. So that's just an entry of 1. 1 plus 7 is 8. -1 plus 1 is 0. 2 plus 0 is 2. 0 plus 4 is 4. And then 3 plus -5 is -2. Perfect. Okay? So you can do those without your calculator. But let's just double check. Guess what our calculator does? It does math with matrices. So I just want to add A plus D. I already have them in my calculator. So I'll just do second matrix, choose A, plus second matrix, choose D, which is number 4. Right? Get them on your screen. So second matrix, A's right there. Hit him.
Oh, you don't have to do the RREF?
Nope, because RREF, that's what you're going to have to keep in mind, is only when you're using it to solve equations. Are we solving equations right now? No, we're just simply adding matrices. You hit enter, look what it has. Oops. Everything we just did. But this is something, guys, addition and multiplication of a scalar, I almost would say just do it by hand because it's easier and quicker to do than like type it all in your calculator and then, you know, okay, so let's do D minus A again. I'll show you by hand. D minus A, you have to go in the right order. You have to take the entry from D first, so -2 minus 3, 7 minus 1, 1 minus a -1. 0 minus 2, 4 minus 0, -5 minus 3. You guys see what I did? I just took all the entries from D and I subtracted all the entries of A that were in the same spot and just do the math. -2 minus 3 is a -5. 7 minus 1 is a 6. 1 minus a -1 is a 2. 0 minus 2 is -2. 4 minus 0 is 4. And -5 minus 3 is -8. And you say, oh, I don't trust my math. We'll just throw it in your calculator real quick. Second matrix, choose D first, minus second matrix, choose A second. And, right? And they'll save it to the very end. They say, your mind is just done. Let's give you some easy stuff. All right. A plus B, guys, what you're going to find is...
You can't do it.
Yes, exactly what I was going to say. So you like try to do it by hand. You're like, they don't match. Like, I don't have entries that match up. So what would happen, like, say you didn't notice that, try it on your calculator. It's kind of funny. He'll yell at you. So second matrix A plus second matrix B, and I'll give you an error message, but notice the error message says dim mismatch, and that just means dimension mismatch. They're not both 2 by 3 or 3 by 2. Okay? So whenever you get an error message, they do always kind of hint towards what the error is, okay? So then we'll just say not possible. So circle this, star this, I don't know what you want to do there. We can only add and subtract matrices that have the exact same dimensions. So they both have to be 2 by 3, 3 by 2, 4 by 4, whatever, okay? All right, the next thing, guys, is scalar multiplication, and it's actually easier than addition and subtraction. A scalar is just a constant that's on the outside of the entire matrix. So just think of like a constant outside of parentheses. You have to distribute that constant to everything inside the parentheses. Well, that's what a scalar product is. You take that scalar or that coefficient on the outside and just distribute to him to all of the parts, okay? So I told you don't worry about putting C in there. Why? Because we can do this fairly easily by ourselves. So 3 times the matrix C is just 3 times literally the matrix C. So guess what we're going to do to every element or every entry? Multiply it by 3, okay? So we're just distributing it to every entry. So you should get 12, negative 18, 3, and 6.
I did that on my calculator.
Woohoo! And you did, and it checked out, right? So that's something to keep in mind. That all this that we're doing, the addition, subtraction, and scalar multiplication, it's pretty easy to do by hand, but you can always use your calculator. All right, so that gets us to the very last operation, which is multiplication. It is something that I'm not going to teach you how to do by hand. It's actually harder than all the other stuff. But some things I want to point out before we do it. So it says, multiplying matrices, however, is much different. First of all, we can only multiply 2 matrices if the number of columns in the first match the number of rows in the second. Then the multiplication itself is not as straightforward as it is with addition or subtraction, so this is quite a process. So for time's sakes, I'll just allow you to perform it on your graphing calculator and we don't have to actually learn it. I do have a YouTube video posted under my course materials on my Math Lab if you want to watch the video about how you're actually doing it by hand. But what I want to point out here is like this second sentence here. We can only multiply 2 matrices if the number of columns in the first, so columns in the first, is equal to the number of rows in the second. Okay? So I want to write an example of that. My head's in the way. Let's say the first matrix we have is a 2 by 3 matrix. Who can we multiply him by? We can multiply him by anyone 3 by something. 3 by 1, 3 by 2, 3 by 3, 3 by 4, okay? So all we need is for this to match, okay? So the example I had in my notes was a 3 by 4, but you said 3 by 2, that's fine as well. So we can multiply him by a 3 by 4. So what I want to note, guys, is to show you the reason why we can do this is because the inner parts match. And what's interesting is since those match, they almost like come together and cancel out. And your answer, the product of these 2 matrices, are the 2 leftovers, all right? What kind of matrix comes out of this product? A 2 by 4. So see how like those kind of cancel out and the 2 by 4 remain. And again, it's more in depth than that we have to get in this class, so we're not going to worry about it. So if you're okay with that, we're still using A and B and all that stuff. Let's go ahead and throw C in there because we want to make sure we have it. So before I flip it over, I'm going to add C to my list. I know Riley said she already did it. So second matrix, I'm going to go edit. I'm going to change my C. My C is a 2 by 2. Okay, I already had them all in there, but I'll just go ahead and do it. 4, negative 6, 1, 2. Okay, so we have everyone in there. So at the top of page 3 here, what we're going to do is all the multiplication. What's important, and this again is more than you guys need to like understand, but you do need to remember, is that matrix multiplication is not commutative. What does that mean? It means in normal multiplication, it doesn't matter the order. What's 2 times 3? 6. What's 3 times 2? 6. It's not going to be the same. So notice A and B, we have A times B and B times A. We're going to get 2 different answers, okay? So the order in which you multiply is very important, all right? So in our calculator, first of all, can we do A times B? We can. What'd you say?
I put it in my calculator.
And it worked, so that's kind of your answer. So notice A is a 2 by 3, and then B is a 3 by 2. So those 3 match, okay? So I'm going to kind of write that off to the side just to kind of keep note of it, okay? So we have a 2 by 3 that we're multiplying by a 3 by 2. So what do you notice matches? The 3's.
And the 2.
What's going to pop out? What kind of answer are we going to have? A 2 by 2 matrix, okay? Before we even do it.
Match too, so what does that?
It doesn't mean anything.
As long as it's
No, it's
different?
the innards have to match. That sounds wrong, the
Oh.
innards. So the column of the first has to match the row of the second. And then what remains is just your answer, okay?
Oh, okay.
So in our calculator, we're going to do second matrix A times second matrix B. and you can just get it on your screen. And look what you get. You get an answer that is a 2 by 2 matrix, which we knew. So your answer is just 8, 9, -4, 24.
I like it.
Okay? B, can we do B times A?
Yes.
We can, okay? And again, I'm just going to write it up top. B was a 3 by 2. And A was a 2 by 3. So what do you notice? The 2's match. So what kind of answer are we going to get? A 3 by 3. Okay? So in your calculator, right off the bat, before we even put it in our calculator, we know it's not going to be the same matrix, right? Because our first one was a 2 by 2. Our second one's going to be a 3 by 3. So it's kind of crazy to think about that. So I'm going to do second matrix B times second matrix A. Look at that big guy, okay? So he is going to be
I like these.
15, 1, 17, -1, 3, -18, 2, -2, 14. Yes.
Do we not have to draw that vertical line?
No, because right now these matrices aren't necessarily representing a system of equations. We don't really know what they're representing right now. You wouldn't be wrong if you did. I wouldn't count it wrong, but we didn't get any kind of system to go with it, so like we don't really have anything to represent our equal sign there. So I totally meant to bring my book, but I wanted to tell you examples like why do we need to know this? Like when are we multiplying things or adding matrices? A lot of things in real life, especially production and marketing, are made up of systems of equations. Like remember that one that we did with the shipping orders, that we had systems of equation for how many total orders we had and then how much it cost for each of the orders. You might add those together or multiply or shift them, whatever it may be. So there's a lot of real life examples that follow matrices. Okay, so you guys are already kind of going along. B is a 3 by 2 and C was a 2 by 2. It is possible.
Oh, I'm thinking of the last one.
You're already ahead of me, that's why. So the 2's match, so we'll have a 3 by 2 answer there. If you guys feel comfortable and you've already worked ahead, I'll just make sure you have the right answer. So the 3 by 2 matrix that you should get is 10, 6, 7, -28, and -4, 20.
We got it.
Does that look good?
Why not?
But then you guys were already looking ahead. Oh, do you have your book? Okay, I might grab the sheet that I was talking about. C times B, so C is a 2 by 2. B is a 3 by 2. And what do you notice about these two guys? They don't match. What happens when you try to do it in your calculator? It'll say error dim mismatch or dimension mismatch. So this again is not possible. Can you pull out for me, Brayden, page 427 and 429? So while he's looking for that, are there any questions? Okay. So what I wanted to do before we get to our other topics is, I have 2 minutes, right? I wanted to kind of tell you where in real life you might see where we would have to add matrices, like what matches that in real life, and where you might have to multiply. Okay, so I'm going to go steal that from him real quickly. Sorry. And if this gets cut off, I'm okay with that. Oh, does it not want to open?
Yeah, it's not the...
Thank you. Thank you so much. Okay. Oh, can I get 429? I don't need that one, but I'm just really not wanting to open it, but
I'm taking that.
you're doing it very safely.
Oh, I didn't know that.
That's the most amazing thing right there, right? Okay, so let me just show you real quickly. Oh, no, this one was going to be, okay, so this one just showed you how if we were going to do it by hand. So if we wanted to do, oh, no, I lied. So where would we might have to use addition of matrices? So here's two different plants that make different kayaks, okay? So one plant's in Madison, one plant's in Greensburg, and this is a production for the whitewater kayaks, the ocean kayaks, and the crossover kayaks. So do you guys see that matrix kind of forming? So you're like, okay, I have this matrix, but why do I care about this? Well, you might add it to a matrix, and it tells you right here. It says, say the production in May. So this is